Hello everyone, hope you can hear me all right. Welcome to my talk. Thank you so much for choosing to attend this talk. I will be talking about implementing custom fragment shaders, and this is not the first time I'm talking about this topic. For the past 2 years, I have been given talks about shaders, and I give it in different ways. I try to do it in an abstract way where I describe to people what are shaders, and I wanted them to imagine the possibilities. And I try to do it from the detail level where I choose literally one use case and spent an entire talk trying to teach them about how that use case can be done with fragment shaders. But over the past 2 years, I have done it multiple times. I have heard the following statements, opinions, or whatever it is. Most of the people, they told me like they have no practical use cases on a day-to-day basis as like as developers. Like you cannot, they are cool, but they are very core. Like you cannot use them on a day-to-day life basis. They are just making for cool art and nothing else. They are super hard to learn, and there are no Flutter examples. So these 4 statements were the theme of the feedback that I was getting most of the time. And my ultimate goal for today, after doing a lot of iterations and a lot of demos, my ultimate goal will be to change your mind at least about one of these. But if it's more than that, I will be more than happy than that. And why I'm so passionate about such a topic, for every villain there is an origin story. For me, it starts with a GitHub issue. That's where I discovered the limits for the first time. Some of the limits I didn't know they existed. I thought that the promise was that Flutter, you have control of every pixel, so you can write any pixel that you would like to, and you can just make whatever cool UI you would like to do that. But I'm pretty sure most of you have seen this at some point when they were learning Flutter or using Flutter. This is a comparison between what happens at the edge of scrolling between Android and iOS. We can see that on iOS, it scrolls beyond its bounds, and it looks very nice, and it's very fun to play with. On Android, I am very opinionated about this, but I really have never saw that as a good one. I thought that was a really terrible UI. Maybe it was good at some point, but not these days. So I was really, I really thought that it should change, but then somehow in Android 12, in 2021, they introduced a new update, and this is what it looks like. This is in Chinese, so that you're just gonna focus on the content of the on the content, not on whatever this is saying. So this is the new stretch effect from Android 12, and afterwards, it's all looking like this. It's much nicer. From initial feedback, it looks so much better. But then after looking at it with more details, I feel like this one is even better than the iOS one. It doesn't go beyond its bounds because we're still scrolling in those bounds, and it gives you the feeling that you are trying to go where you shouldn't go. It's like stretching. So I saw that effect. The second I saw it, on the same day, I went ahead and created a GitHub issue, and a lot of people agreed with me. Some of them are here in the room, so they agreed that this we really need this in Flutter, and as a plus in Flutter, if we can do it with Android 12, we can do it even with Android 5. So that was good. So that's what people were also motivated about, and we now have it in Flutter, and this is how it looks like. It just stretches the content, and it does exactly that. It works if you are using any of the latest Flutter versions on Android. It's going to work by default, and also you need Material 3 enabled. But if we go back to the issue, it is still open, hasn't been closed. So why is that? There is a lot of discussions in the GitHub issue by itself, but this is the best summary I could show you. This is the current behavior that's happening in. If you use the latest version of stable Flutter and you do the overstretch effect, it's going to look like this. It's stretching all the elements at the same value. But then this is what the correct behavior should be like. It's not stretching uniform in a uniform way where all the stretching is happening at the same value everywhere. So here, if the anchor point is the top center, from that point and on. the further we go from that point, the stretching gets smaller and smaller. And I leave it to you. Which one do you think is much better, or which one feels smoother and physically more interactive? I will definitely think that the correct one is better. And I'm sorry for this. This is one of those things where once you see, you cannot unsee. Now you're going to go to your app and you will see the difference, and there is nothing I can do about it. So that's the correct behavior. This is just a high quality detail. And when I'm stretching at the maximum level, you're gonna see this is what it will look like for comparison. And this was the answer from the Flutter team. The reason they can, the implementation that they are using right now is just using a transform widget on the y-axis, vertically stretching all the content, and that's why we get it uniform. And the only solution we have to use in order to create the effect to look like Android is to use a custom fragment shader and apply some custom logic around that. So now we are here. The issue is still open and has more than 90 people who are actually looking forward to seeing this issue fixed, because it definitely would make a lot of make a big difference. What do we have now as well is already a use case. We didn't go into so deep into the talk. We already have a good use case that cannot be done unless we use custom fragment shaders. So I think it's time for us to properly introduce them. We pay some respect to them since they actually are fixing a problem for us. So what are shaders? What's the common thing between all of this? A native app, a web app, Flutter, game, or React Native, or even the operating system? And the obvious answer will be that they are all running on a hardware. So if it's all running on a hardware, then they should have all one mechanism of defining how the pixels are painted. And if we look closer to the device, we're going to end up seeing the pixels, and those are physical items. They are just LED lights. All of these pixels are just LED lights, or another type of lights that we will be able to control their final value, and somehow those pixels are going to end up being rendered as a really nice Material 3 application. So what's the journey of going to render something as simple as a triangle? We will have to follow the protocol that's defined by the GPU, which is the part that's doing all the calculation related to sending any data into the screen and making sure that it's rendering the right thing. So in order to render this, we're going to have to go through something called the GPU pipeline. It starts with the input as usual. It's just math, points, pointers, and all of that. This is an example of how it looks like, trying to define what the points of that triangle are. And then we will have the next step, which is the vertex shader. It's just going to produce a vertex shader, and then we will be able to modify the geometry. We will be able to modify the vertexes as well. In that case, we will have the opportunity of modifying those values. Tessellation is going to make sure that that shape or those points after being connected are all tiled up using elements that that are already supported. So it's going to just make sure that it's not just a big, for example, you're trying to draw a complex shape. It needs to be just the small shapes that that we know how to draw. So that's what happens at tessellation. Now geometry is optional, but it's the step where you can also modify and add new points and modify them, maybe add 3D to it. And rasterization is when all of that data gets translated into something that is pixel aware or real device aware, so that we can actually know what kind of pixel we need to cover. And then fragment shaders is the last step, where we're going to give a color to all of those pixels that are in the area. And by the end, we're going to have a frame buffer. That's what the final result that the GPU produces, and send it to the screen, and then it's being drawn as something like this. And you might say, this is not the triangle I promised you, but it is. It's just we are looking too close. If we look if we look from the big picture, it might still look a little bit, but then if we put it on a device and then zoom out a little, it starts to look like the triangle I promised you with. So obviously, it's just to prove the points of that. Everything that we are rendering is just going to end up in the end as just pixels. But what we also learned is that we had a couple of steps where we were able to modify the output of the step by itself, and they all had something in common, which is they called vertex shader, geometry shader, or a fragment shader. All of those were steps where we had the chance to configure or change the output of the current of the input that was provided us. So we had the possibility of programming. So And all of these is running in the GPU. So that's how we're going to end up with our Wikipedia definition that a shader is a program that runs on the GPU. And to use that definition more specifically for the fragment shader, it's still a program that we are going to write in some sort of language, and it's going to be running on the GPU, but it has one specific goal, and that goal will be to define the color of an item. And how does that relate to Flutter? Flutter still, this is the thing that you probably have seen in the Flutter documentation. We are trying to render anything, we have to go through these steps. And at the paint step, now we have access to custom fragment shaders where we can hook our logic that is a custom fragment shader into the painting layer or at least in our Flutter application. So there are two ways where we can look at fragment shaders in our Flutter world. One is in the framework and the core SDK, and the other is the custom one. So shall we take a look at the example, the basic ones? Since I said that the entire, every app and even the operating system have to go through these steps, our Flutter apps have to do that as well. So if you want to render a small rectangle with a color red, there is a shader, a fragment shader for that called Solid Fill. You can find it, it's on the engine side. All it does is just, it takes a color and it shows that color into the available area that it was provided. Now, the thing that comes next to mind is if we want to do something with more colors into it and they are blending really nicely, that will be the gradient. There is a shader for that, and there are, as you can see, it's inside a folder because there are many types of gradients. So this is the simple one, which is the linear gradient one that is just the one I'm showing you here. But all of these are on the engine side. So these are what people were describing. These are two low-level core things that we do not engage with on a day-to-day life. But I think it was on Android 12 as well. There was a new update to the behavior of when we click on a button. We used to have a ripple effect that is just a circle that gets bigger when we click on something. But now we have something called the ink sparkle. So instead of just showing that circle that gets bigger, we are trying to randomly create dots, and all of those dots are randomly generated, but they get they start to get bigger from the point of attachment. And you can see this is the first shader where we can see that it is on the framework side and not in the engine side. And that tells us that if it is on the framework, it is on our day-to-day life basis. And by the way, this if you say you're not using shaders, excluding all the shaders that are fragment shaders that are in the core engine, this is the in production. So every app that's already out shipped to Android is going to use this one. So that just tells you about the stability of it, whether it's if you ask the question whether you should use it or not because it's not stable or not, this is a shader that's already used in all of our applications. Now, next is my favorite use case. It's the blur one. The blur one is a low-level one, but it's a little bit complicated, and it's just the reason I actually got into blur in the beginning was that it was a little bit slow and they wanted to improve it and find any way that they can improve it. It turns out to be a little bit harder than I thought, but mainly now the Flutter team has actually made a lot of improvements to make it so much faster or impeller. But blur as itself, because we are still dealing with colors in the end, so blur should be also a fragment shader. This is just a snippet. There is also a little bit more code on the function that does the blur calculation by itself, but this is where you can find the code for it. But the question is, are we all okay with this being the blur that we have in all of our application? I don't think all of our applications should have the same blur. Like, if all of our applications have an identity and obviously you can customize everything, why cannot we customize this? I'm pretty sure, I don't know if you can tell the difference or not, but this is definitely not the blur produced by Flutter. This is called, I think it's called, no, this is a Gaussian blur with, yeah, this is hard to tell. Even for me, I've tried to remember all these. Yes, this is a Gaussian blur. And then we have here a surface blur. You can tell the difference, I hope. I think it's very clear, maybe. This is a surface one. This is a shape one that is just on a specific portion of the image. What do we have here? I think this is the, maybe it's the smart blur, but whatever the case, it's different, and this is different, and this is obviously 100% different. This one is different, And definitely this one is different. This one is very famous. You probably have seen it in photography. It's like the style of photography where you take a picture of something and you would like the content of it to look a little bit smaller than it actually is, like a cartoonish Lego movie style. And we have another one. This is like the droidcon. I really don't remember. It's like the lens blur, but it's the one they use in photography when you have a picture and the lights look bigger if you are trying to blur them. But the idea is all of these different types of blur are not produced by Flutter. We cannot use just the blur provided by Flutter to create any of these. So that is not something we are programmers, so we should be able to customize that. So let's give it a try. We go to the Flutter blur, whether it is through backdrop, whether to image filter, whatever it is, the way we are trying to do it, we will have to use one API, which is the UI image.image blur. So if we're trying to apply it on, these are all the possibilities. We can apply it on the x-axis or the y-axis. We can use the clamp mode to produce some different results, but that's it. Those are all the different combinations. But you say that it's in the end just math, so we can create our custom algorithm and do the blur. So it's as easy as going from this picture to that picture. So let's give that a try. So I have here a very simple application. It's just drawing the following. We are trying to apply the blur on this image, and we have a time elapsed just to calculate how long this picture took to make. And then here we have the logic for applying the Gaussian effect. I have that slider over there working all the time, and then I'm going to click. Yes, click the button and now we are back. Yes, that's how long it's going to take if you want to apply the blur using the CPU. So you get the point. It's not going to perform well. It's not going to take you anywhere. And that's the difference between using the CPU and the GPU. So if the logic that I just applied is going to go through every single pixel, go to the neighboring pixels, find some sort of an averages and some sort of algorithm, and then go through all the pixels doing the same thing, and then it will end up with the blurred image. But as you can see, it takes a long time, and that's because it's doing it one pixel after the other in a synchronous way on the CPU. We can obviously optimize this by putting it in an isolate, or by dividing the workload onto different places. But you will never be able to 10x or 100x the speed of doing this. That's why the GPU is made. It's literally made for such a thing, doing a lot of things that are very similar at the same time. So that's where custom fragment shaders are coming to the rescue. That's where we will be able to use our coding to make something like that work better. So first of all, I'm going to start with the most basic shader. That's all that we're going to need to do, so that I can show you that it's actually really easy to work with shaders, or at least to start with them. So I'm going to do the most basic bare bone. I'm just going to double check the time. So this is a bare bone project. It doesn't have anything on it. So it's just the basic Flutter application. All I'm going to do, create a new folder called shaders. I'm going to add my first shader here. Let's call it solid, and then we're going to call it frag. Frag is just a short for fragment shader. We can also call it GLSL because that's the language that we will be writing in. The next thing would be to add the shader into PubSpec, because these shaders are going to be compiled, so Flutter needs to know about them. So we'll add them to PubSpec to YAML here. And I definitely didn't get the indentation right, but I hope I will. I hope it's all right. No. Let's see. Let's see in a bit. One, two. Yes, it's the indentation is right. Now I'm just gonna go here into the application, and instead of drawing whatever I'm trying to draw here, I will change it while the application is building. I would remove all of this unnecessary stuff. And still using a material application. And sample app So we will start by creating our custom painter here. That will take, let's give it size first. Give it 200 by 200. And then we have the shader, or the painter, sorry. Painter. I literally forgot how to write. And no, extending it. Should have watched the previous talk, the previous one. Custom painter. Then is it extend or implement? Okay, so I think this is what I want. I'm just gonna return no optimization, and it's gonna need a fragment shader. Call the shader here, and then canvas draw. We can use the shaders with any draw method. Like, is it to draw rectangle or is it to draw line, whatever it is. Just gonna provide it here with the area that we'll be rendering something in, and maybe 0, 0. Shader. So now all this boilerplate is just to get us to a point where I can pass it into the application, and then here now we need the shader. So where are we gonna load that from? For that, I mean, there are so many ways we can do it, but I definitely prefer using a library called Flutter Shaders. It's just a wrapper around the simple API, so it makes it so much easier to work with shaders and load them. But it's maintained by one of the Flutter team members, so it's probably very safe to use. So we have here a widget called Shader Builder. Provide it with a shader asset. It's called solid frag. And then we have a build method that takes a couple of weird arguments. They are called context, shader, and widget. Okay, context, shader, and widget. And this one we can return widget, but we'll just need to provide it with a shader over here. Okay, thank you for debugging with me. And now if I run this again, I mean, this is all just to showcase that, like, I could have just shown you the example there, but it's all just to say that even in a stressful environment like this, you could start doing shaders. So it doesn't, you do not have an excuse not to say that they are really hard to set up. So now I'm going to write a little bit of code for the shader. It needs an entry point just like anything else. It's going to be void main just like C++. It's going to need a frag color, which is the output of this entire thing. And the color, as we've seen, like at the low level, is just represented by 3 values. But then there is also the fourth one, which is what is it? Which is the alpha. So let's try to render something over here. On the red channel, it's going to be 0. It's going to be 1, and on the other channels, it's going to be 0. and then it's going to be absolutely visible to everyone. And the last thing to say is to define that this is going to be our output color from this entire thing. So if I run it again, maybe it will run this time. So let's see, this is the simplest shader I could ever come up with. If it doesn't compile, we'll just need probably to add 1 or 2 more things. And why I'm hoping is because there is actually no debugger. So if we get the error, we're not going to be able to, obviously it's not going to allow me to run the application, but the thing that you have to understand is that this language called GLSL, it doesn't have a compiler because it's not running a step after step. We cannot put debugger and then try to debug or put print statement or anything. So that is the part where it gets a little bit hard. And now, yes, I have the screen, it's red, and that's all I needed to show you here, just to showcase that it was really easy to set up, but even on a stressful environment. Now for the cold ones. So this is the first one. We were able to get it in a few minutes, but the important ones are this one. So for example here, this shader is obviously using the same mechanism that I used before. It's just rendering us this really nice and dynamic background. You might say, what's the use case for such a thing? Because that's what I was always getting. This is cool, this is art, but what's the use case? Well, there are so many use cases. For example, if you have a music player app, and you probably have seen any of the modern music player apps, they really have a really nice, a nice dynamic background to them, and this is an example where you can do that as well. So that's an example. This I saw in Twitter. I don't know if any of you have seen in Twitter as well. It was popular in the iOS community, but literally just found it. It was open source. They made it using a metal shader. I took the shader. Within a few hours, I've got it working with Flutter, and it's just an example of the ink sparkle. Like if you want to do something customized like the ink sparkle, this is what we can actually produce as well. So in an app where it's a game or something else, this is really fun. This one was one of the demos for WWC of this year. It was introducing how you can use fragment shaders, but at the same time, it shows a very cool example how we can apply this not just on an image. It means we can apply this on any widget. So a ripple effect on your widgets. This is something to add a lot of visuality to your application. This is another example. I'm showing this on desktop because this is where it makes more sense. These buttons are really cool, and once you want people to click on a button, you really want to make it a little bit more dramatic. So here it's moving, and I really want to see what happens when I hover on it. But now I really want to click. Is there something ever going to happen? But obviously there is nothing, but it's just going to make me feel that. This one, how many of you have seen this one? I hope some of you have seen this one. Okay, a few of you have seen this one. So this one was the demos I made, and they went viral for some reason. So for iOS, there was a feature where if you put 2 phones together and you share your details, maybe you can try it with any of your friends. Both of them are on iOS, and they share the details. It's going to do like a really crazy nice animation. I saw that. I was like, well, Flutter is cross-platform, so should we do it for Android and iOS at the same time? Obviously, it's not sharing any data, but the gist of it is the effect. The effect is doing stretching, is doing blur, is doing all kinds of things, but I didn't write it. It wasn't metal, but I ported it into GLSL. But it shows when we are working with low-level stuff, how cool it gets by being able to share the code with other communities as well. This one, maybe this one you have seen. Has anyone seen it, please? Because I've definitely, otherwise LinkedIn has given me inflated stats, like over 200,000 people, they said they have seen it. But this one is, I don't think it has audio, but I hope it, anyway, it does have audio or not. It's really just a cool demo. Shows that if you wanted to remove an item from the list, instead of just swiping left and removing the element, make it feel a little bit more painful. It's like you're taking that thing, and then there is if you see the real demo, you're going to see how cool it is. With the audio, it's just really feel painful to remove an image. People really know that they're actually going to remove something. So that's another use case. This one, all of you who have a financial application that has cards, you might want to use this. There is a feature where you freeze the card of the user. So instead of just saying your card is freeze, maybe just go ahead and freeze the entire thing in front of them so that they know it's actually freeze. So I use this example, and then This is what happens when you freeze it, and then when you unfreeze it, so it actually animates. There are so many freezing effects, I don't know. This one was my favorite because it felt like it doesn't freeze the entire thing, but it makes it very clear that your card is frozen. This one is not as visually good as the others, but it is actually as practical as them. So here what you are seeing is just PNGs and SVGs. All of them have transparent backgrounds. And as we know in Flutter, if you would like to put a shadow on anything that is not rectangular or a circle or a line that is defined by the paint methods, you cannot put a shadow on it. There's no way. So this one here is like using a custom fragment shader in order to apply the effect on any of the pictures that are here. And I'm just showcasing that it's actually fast and it works even with larger images, because the problem with these shaders is that because they are applying on every single pixel, it gets a little bit slower after you add it to after the pictures are trying to be a little bit larger. And this one here is also very customizable. Like you can make the shadow like on just one side or multiple sides. Here I'm just trying to showcase it like it's 2D, but it's going all over the place. So that's another use case. And now these are some random experiments. I really did not want to qualify them as actually great use cases. This one, for some reason, I just did it. It's just like the Mike Genie effect. It looks cool, but doesn't serve anything. This one brings me to one really big use case for fragment shaders, which is on the other world of gaming. You might have seen a game made by Hina, and this was like fully made with shaders. And this is another use case, which is in games, they usually end up being so large in size, and they really don't want to use PNGs all over the place to create their assets. So especially if the assets are just like textures on elements. So this is one of the other examples where I ported this one. It was metal shader, is like a leather metal shader, and they ported it into GLSL and just added a little bit of effects to it to make it look better showcase for the demo. This one, I don't know, I just don't see it correctly, but this one here, I saw one person complaining that the Android weather application is not as cool as the iOS one. So I just tried to replicate at least one of the screens where what shaders here, obviously, as you can tell, is the snow behind the scenes. So we wanted to do the snow in a way that it's not actually gonna literally make the UI junky and not operatable at all. This one is another random experiment. It takes three positions from the picture. So the background that you are seeing over there in the behind the scenes, it's actually dynamic. It's not a background that we already provided the values for. So it's actually really smooth. It just takes 4 points. I did not want to do like read the texture of every single image one by one. I wanted to read like very specific ones, so it can be very fast. But it has use cases. You can imagine some of that. This one was someone asked me. They have seen that in Instagram, when they show the profile image, they don't just blur the background, they actually blur it and pixelate it. So what's the other solution? Is just using fragment shader to make a pixelated blur. And now this was just a random experiment of making an app bar that works with different types of blur. And now we're going back to the big league. So all of the blurs that I was trying to show you earlier, trying to say that they were very hard to do. Obviously, they were just screenshots from a Flutter app that I made and implemented all of those custom shaders. And so all of them were just Flutter. Now, I needed my revenge. So I created the issue in 2021. And since then, I've done so many shaders. And the obvious shader that I wanted to do was obviously to do the stretch effect, the thing that we have seen with Android, because that's, as we can see, that's the biggest use case, and a lot of people agree with that. So what I tried to do here, let me show you the example, is I'm definitely not going to rewrite everything like I did a few minutes ago, so I'm just going to show you the setup here. Like I have this very basic material application. This here is just showing us the case when we are using the Flutter default stretch behavior. And now if we enable the blur one, it's going to look like this. Obviously, this is just me playing with it. So I have the following shader. This is the shader that I'm going to be modifying for a little bit, where I can do more effects. So here, I'm just getting an over scroll value, the texture and the height and the width and all of that. But I want to do what they said. I want the stretch to become less and less as we move away from the main, from the anchor point. So how do we do that? Like here we are just, this is where we are modifying the value. So let's say, for example, I want to make it larger. So if I multiply it by 9 again, you're going to see that it's going to be, it's just going to get much and much larger. Let me make sure that I'm running the correct one. Yes. Yeah, it's definitely much larger. So let's bring it back to where it was. And now the way because the coordinates are provided to us in a way that we are normalizing them now. So this value UV on the y-axis is going to be 0 at the top and 1 at the bottom. So if I can use those numbers in order to play with how much I'm doing the stretching. So let me try to do that here. I'm definitely not going to try to remember all of that on stage. And if I try to do the stretching now, you might see that it's actually different. It's like stretching a lot at the top, but stretching, it's like squeezing at the bottom. So we are getting there, right? I don't know, like it feels right, but I really, really wish that there was like a way where I could get the correct values because, what? That. I really wanted the correct values. I don't know. That was my wish, but I don't know. I hope they are not in. Okay. So it says your wish has been granted. Android is open source, so let's give it a try. So Android is open source. Take a look at the code, and the code for open source is in C++, but they have this shader part where they say, this is the logic where we are using for our stretch effect, but it's just in SQLS. So what do we do about that? We just, hours later, gonna end up with the effect that's using the real effect from the Android and just ported that into Flutter. I actually had this one. I was able to finally do this one as of last week. I was about to make the PR, but I was like, you guys deserve to see this first here before I make the PR. So that's my biggest, that's the PR that I'm trying to make right now. And this is the biggest, the best shader I have so far. So all of those are the demos. Now, what do you want to do? What you want to do is just find a use case for yourself. So if we wanted to summarize all the use cases that I was trying to show before, it's one of the two. One is where we draw something as fast as possible, or we do real-time image processing. So we did draw something as fast as possible with the chaos button. We did that with the gradient background. We did real-time image processing with the image when we do the ripple effect on it, when we try to remove an element with a curl effect. All of those were image processing, because when I say image processing, it means that we are literally doing widget processing, because the reason we are able to apply any of these on widgets is because they are being translated into something called GPU images, and we get that value back in Flutter synchronously. So that's why they are real time, and we can provide those widgets as images or bitmaps into the shader that then we can process as fast as possible. These are some of the use cases that you can also go beyond, which is like, we have seen that we can do pixel level control, such as things where we can do our own blur effect. We have seen UI optimizations where you will probably see it, where if we do the blur on the CPU, it's not going to work. But if you try the GPU, where I have shown you the example where we use the blur and we are still scrolling, the frames did not drop, but the GPU usage was increased a little bit. And that's it. I guess for further learning, you could watch the main Flutter resource about using custom fragment shaders, Flutter build show. There is obviously a little bit of documentation on that. We have the Bookshelf shader in order to learn about really writing fragment shaders themselves. And one more thing is to address the final bit, which is that there are no Flutter examples. Together with Matt Carter, you might know him as Super Declarative, we made something called fluttershaders.com, and it's now already public. You can go take a look at it, and it's a place where we want to share shaders that are actually useful, but not just cool, like really useful. And what you will see there, you will see the image of how it looks like. You will see a video how it's operating, and you will find the code with all the licenses and everything. So It's not like Shader Toy. Shader Toy, you're going to go there, you're going to take the code, and it's not going to work in your Flutter app. But this, what we are trying to do, we are trying to take on Shader Toy, but it's just for Flutter. So what we are trying to do is we're trying to provide you with code that you can literally copy and paste into your Flutter app, and it will work out of the box. All the examples that I have shown today are available on my GitHub, and I always share, like I've been sharing a lot of code demos for the past 2 years, and that's where I do most of the time on Twitter. That's all. Thank you so much.